presenters for this session. I'll call their name one by one to please take their seats on the dais. Professor Kamal Jain, Department of Civil Engineering, IIT Roorkee. Sri Stephen Potterson, Senior Vice President, Railway Division, Getzner, Austria. Mr. Christoph Wilczek, Head of Track Analytics, Plasser India Pvt. Limited. Sri V.N. Singh, Vice President, Hultas Transrail Limited. Mr. Cesare Santanera, CEO of DMA Italy. Sri A.T. Pramod, ENE COM. Sri Tanu Jhunjhunwala, CEO, Planis Technology, Chennai. Sri Abhishek Pandey, Business Development Manager, Hexagon, India. Sri Kasturi Srinivas, Bentley, India. Sri Amit Sharma, Director and Founder, Matrix Geo Solutions. Sri D.K. Jain, DGM Research, SAIL, Ranchi. And Sri Sagar Mishra, Director, Trimurti, India. May I request all these presenters to kindly take their seats on the dais, please.
Ladies and gentlemen, this is technical session 4, and the subject of this session is trade and industries. Since this presentation is about trade and industries, all the industries related with railways. So the problems that these industries have been facing and the success rates that has been achieved by them is being shared here. So the views and opinions are very important for us. So the 4th technical session caters to that need. Now, ladies and gentlemen, I'd like to request Shri B.S. Meena, the Chief Engineer of Construction 3 Division of Northeast Frontier Railway, to kindly accompany the Chairman of this session, Shri A.P. Mishra, former Member Engineering, to the dais. And also, the Co-Chairman of this session, Shri Alok Kumar, Chief Administrative Officer, Construction Northern Railway, to the dais. Thank you so much, sir. So we have the chairman and the co-chairman along with the presenters of this session seated. I'll now request the chairman of technical session 4 of this international technical seminar, Shri A.P. Mishra, to kindly take over.
Esteemed audience, a very good afternoon to all of you. This session starts with a delay of about an hour and a half. I don't want that the lunch is delayed by an equal amount of time. So I'll try to restrict this session to about an hour and 10-15 minutes, although the allotted time was an hour and 45 minutes. So we have 12 papers. I'm very sorry, but I have to request the presenters to restrict their presentation to about 5 to 6 minutes. At the 5th minute, Mr. Alok Kumar will ring the bell. At 6 minutes, the second bell. And after that, it is up to you. So this is a very important session in which till now we have heard the users. Now it is the suppliers, it is the innovators, it is the industry, which is an equal partner in the development of track technology in the Indian Railways. So I hope this session will be very productive and there will be an active participation between the user and the supplier. The first presentation will be by Professor Kamal Jain from Department of Civil Engineering, IIT Roorkee. The subject is Unmanned Aerial Vehicle a game changer in modern surveying techniques. Professor Kamal Jain.
Good afternoon to all of you. The topic is selected because I feel teaching photogrammetry that surveying is going to change, surveying technique is going to change, and UAV may be the main reason. UAV, all you know, just to introduce. It is not more video mode. क्या slide में? इसी को. So all of you are aware. So just briefly. To define, UAV is three components. One is air vehicle, second is control station, and the third one is communication, which link air vehicle with the control station. Recently, DGCA is finalizing UAV categories. The 5 categories are defined, and it is based on the weights which it can carry. The first one is nano, up to 250 grams, micro to 50 grams to 2 kg, and then mini, small, large, above that. Mainly UAVs, what we are using for engineering purpose is in the category of nano and micro. Mainly, you know, this is only a platform, so if I compare it, it is, we can say platforms are satellite or aerial photography, and now it is UAV. So the process is almost similar to aerial photography. So the process, the first part is data acquisition, data processing. Here the difference is data acquisition. Just to, you know, I'll not be going in theory, but to tell basic of this. In data acquisition, here we are using non-metric camera, and in photogrammetry we use metric camera. Accuracy of, you can assume the accuracy of metric camera, the cost is almost 5 to 10 times. Data processing is almost same. Only difference is in aerial, you are able to edit the model. Here you don't have facility to edit the model. So to make, so first part will be just to make camera metric, it has to be calibrated. That means the focal length and center should be calculated. Now the topic is because it is a game changer, so the basic was plane tabling, survey, and the second part was aerial was also parallel. So by 90 I can say total station taken over plane table, and by 2004-5 GPS started taking over, and simultaneously laser also. With the advent of satellite stereo images, 2000, say Indian satellite 2005, stereo satellite images were used for third dimension, and now in last 2-3 years UAS is taking over, trying to take over. Just to give brief difference, satellite is, you know, it is regularly covering the earth, already we know, and but the resolution is less, and because of resolution and the accuracy in 3 dimension and planimetry is also limited. The most popular have been for last 30-40 years was manned aircraft, which gives the required accuracy. But only thing is it's costly, and in India especially you have flying limitations, so it is not so free. UAV now, because there is no restriction and we started using it, so it is almost, we are trying to replace aircraft, manned aircraft, and the limitation I'll tell you. The last one was terrestrial, which gives best accuracy, but again it is very slow, you can say. So we want to compromise between the speed and the accuracy. application especially, initially UAV started only for recreation. You can see for now for marriage photography, but recently you can see in last 1 year when the government wanted to monitor the progress, they started using for that, we call it non-military purpose. The sensors are in photogrammetry, we say platform and sensors. Similarly, in UAV also we have platform and sensors. The sensors are almost same sensor. Multispectral normal panchromatic camera, multispectral, hyperspectral. I'll not go in detail of that, just I'll say multispectral, hyperspectral especially are used for resource mapping. Then thermal and LiDAR was especially for 3-dimension only, but the same job is done by photography only. It can be done by photography. Thermal we are trying to use for fault detection in railway line. Application, you can say the same process as photogrammetry. I'll just skip this and I'll show you the result because I want to show some slides, video. The outputs are 3D point surface, already we know. Like this you can see, this is called orientation or triangulation, where all the photographs taken are position are calculated, and from the position we calculate the point cloud, and from point cloud we create the ortho photographs. You can see now this is the bottleneck which I am saying. If you just create a contour map of the point cloud, that is a DCM, we call digital surface model. Point cloud should be created from DM. So far in UAV this facility is not available, and it gives error that way. So we have given method to correct this. Now you can see the second part was digitization. You can see here there are two parts, two cursor red color, left image and right image. So here the editing facility so far is not available in any UAV software. This is given which is equivalent to photogrammetry, and this gives you accuracy of centimeter now. And this we have proposed in smart city. Now this small video geotagging, this we have proposed because you know everyone is talking about recording the area. Now here you can see special is the track is recorded as usual by video, but on the right side you can see a map. On map we can see the position of point, where it is moving. Just last video. You can see here, we can see video before maintenance work and after. This was for a canal in irrigation. So right side you can see it is, we are seeing the position on map, and left side we are seeing before and after. Just one more slide. This is the latest one, you know, because maintaining in GIS, railway is going for that because we are working for last many years. So we know that now bigger issue is coming, big data. How to handle the data, because when you have so many video and other things, how to handle the data. So this technique we have given. On web server you have you can see all the tracks which are there, and you click on any track, automatically the video will play for that track like this. And on the right side also we have given facility that you can store anything, you want to tag anything, that also you can do like this. So anyway I click, I can play that area. I think that is all. Lastly, if you allow, This one is, once the ortho image is created, this is again we have given that this can be loaded on Android mobile, that software we have given. So that now in the field you can go satellite in the background, and we have given GPS solution also in RTK mode. So exact with sub-centimeter accuracy you can do layout without establishing control pipe, which is a very costly job when already first order, second order. So here you do away with all first order and second order surveying. Thank you.
Thank you, Professor Jain. Very nice presentation. I must say that I hate restricting the speakers to such a short time for their presentation. They are repository of knowledge, and they have worked very hard in writing the paper and making the presentation. But all of you must realize that this is only because of the very, very serious paucity of time, and with a very heavy heart that I restrict the time. So please cooperate in this. The next speaker is Mr. Stephen Potokan, Senior Vice President, Railway Division, Getzner, Austria, and his topic is under-sleeper pads for bedding optimization in track and turnout. Mr. Potokan, please.
Thank you. As I just have 5 minutes time, and then the clock will ring, I will not even try to explain anything because it's totally unnecessary. So if you have any questions more detailed about the topic I'm talking, please come to our stand. We can have a short discussion there. I will just rush through some slides, show you some pictures, and give you some impression what the company is doing and how we can help you to improve the track. I guess everyone knows pictures like that. Rail corrugation, you have broken sleeper in a track, you find degraded or destroyed rail pads, and one of the most severe things you can find is destroyed or degraded ballast. If you're increasing your loads, your traffic, you will find also pictures and transition zones like these white spots, degraded ballast, but also differences in settlement. Why you find that? The easy answer is you're overloading your system. Single components are overloaded, and therefore the idea is to change that by introducing some designed elasticity into the track. You try to set this, you try to spread the load to more components and therefore unload or reduce the load per component significantly. This is the main idea by using designed elasticity. You shouldn't use too soft elasticity, otherwise you will get some problems with rail deflection. I have prepared some examples. One of it is a turnout. Everyone knows that there are problems with turnouts. They cause a lot of maintenance. They are quite expensive. They are difficult to maintain. So an optimization would be good. How the optimization works would show this video, but due to the lack of time, I will skip that. So I will not explain how it works, but I will show you the results if we help you to optimize the turnout. These are 4 turnouts in an Austrian track. 2 of them are equipped with elasticity. In that case, it's under sleeper pads. And they were compared with unpadded turnouts just to see the benefits for the necessary maintenance. If you look at the tamping intervals necessary for this turnout, you have the comparison between, on top it's the tamping intervals within 2003 to 2016, you need to temp 5 times the complete turnout. If you use the optimized turnouts by under sleeper pad, the result was that you could reduce the tamping intervals to just 2 times tamping in the same time interval. And what you can also see, the complete curve is a lot more homogeneous. So the total quality when the tamping was done was a lot better than without these pads. If you ask yourself where we are doing this, if the results are that good, there are a lot of countries doing it as a standard already. We are doing it in Austria, Germany, all over Europe, in Italy, but also Scandinavia. So we have a lot of references to do that. How we get the benefits, as I said, we are introducing elasticity into the track. We have, for a ballasted track, 3 different options. We can use elastic rail pads, we can use under-sleeper pads, or we go below the ballast by using ballast mats. Just for a short introduction about the sleeper pads, you have mainly 3 effects. You are increasing the contact area to the ballast, which is reducing the load significantly. You're, as I said, distributing the load to more components. And the third effect is, if you already have a better track quality, you're also reducing the dynamic loads introduced into your system. So all these 3 effects will give you benefits for your track. Here you can see the difference in contact area. You increase it up to 35%. Again, show you the results of a test. Here is a test track in Austria. We have tried to find out what effect we will have if we are reducing the ballast depth. So the test track are 4 sections. We have regular section with 30 centimeter of ballast depth and no elasticity. Then we are going to a section with 30 centimeter with under-sleeper pads. Then we tried a section with 20 centimeter of ballast depth with under-sleeper pads and another reference section with 30 centimeter and without elasticity. The picture you can see there is a straight track, so the condition is quite similar over the complete overall 4 sections. If you look at the degradation of the reference section, you can see that there is some kind of track measurement done, and from 2002 to 2013 you get regular degradation, and some tamping intervals will increase the quality. This is the section with 30 centimeter compared with 30 centimeter of ballast and under-sleeper pads. This is the section, same measurements, with 20 centimeter of ballast and under-sleeper pads. And this is the reference sections without under-sleeper pad and 30 centimeter of ballast. So you can see even with 20 centimeter of ballast and under-sleeper pads, you have a better track behavior than you had without these designed elasticity. Another option are the ballast mats. I'll also show you another example. Here is from Union Pacific, it's in the US. You have a 36 tons axle load, heavy haul track, and you have a small bridge there. You can see on the picture a small bridge. There you have to repair the bridge every year because the load on the track is about 250 GMT per year. So after 1 year, the bridge always looked like that. So you have an alignment problem, so you have to repair the complete bridge every year because of the high loads. What we did, we installed some under-ballast mats there to protect the ballast and to have the same elasticity before the bridge as well as on the bridge. This is the result after 500 GMTs. You could see without any maintenance, you could see no degradation of the track. And another picture after 750 MGTs, still no damage of the track. You not even need a track recording card to see these results. We also use that with just 150 millimeter of ballast depth. This is in London, Gauss Bloke, with all the very good results. Thank you for your attention, and as I said, it's very difficult to explain anything in just 5 minutes, but I tried to do my best to catch up some time. If you have any questions or if I caught your interest how we are doing it and how this can be done, please come to our stand and we can answer you some questions there. Thank you.
Thank you, Mr. Stephen Portocan. Now the next speaker, I apologize if I am not able to pronounce his name correctly. It is Mr. Wilczek, Head of Track Analytics, Plasser India Limited. His presentation is on latest developments related to state-of-the-art monitoring technology for track maintenance. Mr. Wilczek.
Take up one idea, make that one idea your life, think of it, dream of it, live that idea. Let the brain, muscles, nerves, every part of your body be full of that idea and just leave every other idea alone. This is the way to success. This beautiful quote by Shri Member Engineer Gupta that was brought in the keynote is nice summarization of the spirit that I get here from this audience. And I think worldwide there is a huge community that also lives by the spirit of providing safe transport to various nations. And in this spirit, my colleague Florian and I joined Plasser because our machines are supposed to be a part of the integrated system. So we are deeply founded in the asset management of railroads, and these are our major takeaways from our experience, and also when we travel and talk to different track engineers. Well, traffic load increases, total cost of ownership should go down, reliability should go up, and availability of skilled workers goes down, and service life needs to go up. So these challenges are true everywhere in the world.